In a world driven by innovation, where artificial intelligence shaping the future, one academy stands at the forefront of technological advancement. Welcome to Manifold AI Learning, where we are proud to present the LLM Ops Masterclass. Join us on a transformative journey into the heart of AI operation as we delve deep into the ML Ops, generative AI, data science, and artificial intelligence. From understanding the fundamentals to mastering the advanced techniques, our comprehensive curriculum will empower you to excel in the dynamic world of AI. So these are some of the testimonials that we have got from our previous learners of this batch. The LLM Ops Masterclass completely revolutionized the way I approach the AI project. I feel confident tackling real-world challenges and driving the innovation in my field. Another learner says that the hands-on projects were incredibly engaging and gave me the practical experience that I can apply in my career. I'm grateful for the opportunity to learn from the industry experts. So guys, don't miss your chance to be part of this AI revolution. Enroll in the LLM Ops Masterclass today and unlock your potential with Manifold AI Learning. In a world driven by innovation, where artificial intelligence shaping the future, one academy stands at the forefront of technological advancement. Welcome to Manifold AI Learning, where we are proud to present the LLM Ops Masterclass. Join us on a transformative journey into the heart of AI operation as we delve deep into the ML Ops, generative AI, data science, and artificial intelligence. From understanding the fundamentals to mastering the advanced techniques, our comprehensive curriculum will empower you to excel in the dynamic world of AI. So these are some of the testimonials that we have got from our previous learners of this batch. The LLM Ops Masterclass completely revolutionized the way I approach the AI project. I feel confident tackling real-world challenges and driving the innovation in my field. Another learner says that the hands-on projects were incredibly engaging and gave me the practical experience that I can apply in my career. I'm grateful for the opportunity to learn from the industry experts. So guys, don't miss your chance to be part of this AI revolution. Enroll in the LLM Ops Masterclass today and unlock your potential with Manifold AI Learning. In a world driven by innovation, where artificial intelligence shaping the future, one academy stands at the forefront of technological advancement. Welcome to Manifold AI Learning, where we are proud to present the LLM Ops Masterclass. Join us on a transformative journey into the heart of AI operation as we delve deep into the ML Ops, generative AI, data science, and artificial intelligence. From understanding the fundamentals to mastering the advanced techniques, our comprehensive curriculum will empower you to excel in the dynamic world of AI. So these are some of the testimonials that we have got from our previous learners of this batch. The LLM Ops Masterclass completely revolutionized the way I approach the AI project. I feel confident tackling real-world challenges and driving the innovation in my field. Another learner says that the hands-on projects were incredibly engaging and gave me the practical experience that I can apply in my career. I'm grateful for the opportunity to learn from the industry experts. So guys, don't miss your chance to be part of this AI revolution. Enroll in the LLM Ops Masterclass today and unlock your potential with Manifold AI Learning. In a world driven by innovation, where artificial intelligence shaping the future, one academy stands at the forefront of technological advancement. Welcome to Manifold AI Learning, where we are proud to present the LLM Ops Masterclass. Join us on a transformative journey into the heart of AI operation as we delve deep into the ML Ops, generative AI, data science, and artificial intelligence. From understanding the fundamentals to mastering the advanced techniques, our comprehensive curriculum will empower you to excel in the dynamic world of AI. So these are some of the testimonials that we have got from our previous learners of this batch. The LLM Ops Masterclass completely revolutionized the way I approach the AI project. I feel confident tackling real-world challenges and driving the innovation in my field. Another learner says that the hands-on projects were incredibly engaging and gave me the practical experience that I can apply in my career. I'm grateful for the opportunity to learn from the industry experts. So guys, don't miss your chance to be part of this AI revolution. Enroll in the LLM Ops Masterclass today and unlock your potential with manifold AI learning. In a world driven by innovation, where artificial intelligence shaping the future, one academy stands at the forefront of technological advancement. Welcome to Manifold AI Learning, where we are proud to present the LLM Ops Masterclass. Join us on a transformative journey into the heart of AI operation as we delve deep into the ML Ops, generative AI, data science, and artificial intelligence. From understanding the fundamentals to mastering the advanced techniques, our comprehensive curriculum will empower you to excel in the dynamic world of AI. So these are some of the testimonials that we have got from our previous learners of this batch. The LLM Ops Masterclass completely revolutionized the way I approach the AI project. I feel confident tackling real-world challenges and driving the innovation in my field. Another learner says that the hands-on projects were incredibly engaging and gave me the practical experience that I can apply in my career. I'm grateful for the opportunity to learn from the industry experts. So guys, don't miss your chance to be part of this AI revolution. Enroll in the LLM Ops Masterclass today and unlock your potential with manifold AI learning. In a world driven by innovation, where artificial intelligence shaping the future, one academy stands at the forefront of technological advancement. Welcome to Manifold AI Learning, where we are proud to present the LLM Ops Masterclass. Join us on a transformative journey into the heart of AI operation as we delve deep into the ML Ops, generative AI, data science, and artificial intelligence. From understanding the fundamentals to mastering the advanced techniques, our comprehensive curriculum will empower you to excel in the dynamic world of AI. So these are some of the testimonials that we have got from our previous learners of this batch. The LLM Ops Masterclass completely revolutionized the way I approach the AI project. I feel confident tackling real-world challenges and driving the innovation in my field. Another learner says that the hands-on projects were incredibly engaging and gave me the practical experience that I can apply in my career. I'm grateful for the opportunity to learn from the industry experts. So guys, don't miss your chance to be part of this AI revolution. Enroll in the LLM Ops Masterclass today and unlock your potential with manifold AI learning. In a world driven by innovation, where artificial intelligence shaping the future, one academy stands at the forefront of this LLM Ops Masterclass. First of all, guys, thank you so much for enrolling. We are proud to present the LLM Ops Masterclass. Join us on a transformative journey into the heart of AI operation. Pleasure to interact knowledge through manifold AI learning. Now, this is how your learning journey would look like as part of this LLM Ops masterclass. Here, in your learning journey, you'll start by understanding the generative AI. What exactly is this generative AI? Then, you would progress and understand about the prompt engineering, the technical details of large language models, and followed by implementing your project one, where you will go ahead and build an AI application using the ChatGPT. Then you will go ahead and implement this LLM ops techniques using the industry standard tools, that is usage of Git, GitHub Action, and implementing it on the Kubernetes cluster. Then you will move ahead and implement your project number two, which is about building an AI application using the Hugging Face models. And at the end, you'll also learn about how you can monitor your large language models in the production environment. As you progress in your learning journey, you will gain the deeper understanding of generative AI and its practical application. You will learn the essential techniques for deploying, monitoring, and optimizing your large language models and the machine learning models in the production environment. You will explore the transformative potential of generative AI in various industries, and you'll also navigate the diverse landscape of artificial intelligence and discover the emerging trends and the application. Now, to get the most of this course, we recommend you to practice the hands-on. We recommend you to perform the hands-on coding and the assignment. And lastly, stay committed for consistent learning. At least aim to improve 1% every day. With that, you get the maximum benefit out of this course. Now, to help you further in your learning journey, you'll also get the additional resources for download, that is the slides PDF as well as the source code, so that you can progress in your learning journey. So folks, thank you again for enrolling with us, and let your learning journey begin. Hey guys, thank you so much for joining in on this session on the hands-on machine learning. Will be starting on time at 5 p.m. IST. In the meantime, if you've got any question, feel free to let me know, team. Okay. Hey everyone, thank you so much for joining in and welcome to your learning journey, folks. And the agenda of this session is to continue further on the chapter number 5 from the book of hands-on machine learning here, Scikit-Learn TensorFlow. So, in the last session, we had an introduction and we have actually implemented the support vector machine. Now, as we progress in this session, we would go ahead and continue further and dive deep into this support vector machine and we'll take a learning journey from there. So, folks, before we get started, I hope everyone are doing good and everyone are able to hear my voice and see my screen. Can you please confirm if you're able to do so? Okay, thank you, Rajiv. Thank you, Rakshit. How about others? Are you able to hear my voice and see my screen? Lakshmikant, Sridhar, Gopinath. Okay, thank you so much everyone for confirming and thank you again for joining in on this live streaming on our learning journey of hands-on machine learning here at Scikit-Learn, and currently we are in the chapter number 5. Now, before we proceed ahead, guys, do you have any questions or do you have any queries from the learning journey that we had? So please let me know. Okay, I can see few learners are requesting in Hindi. I do apologize. I'm not much aware of Hindi. I can speak in the regional language which I'm in, that is Kannada, English. So those are the two languages that I'm comfortable with. Okay, I'll do my best to keep it simple, but in case if something is not clear, please feel free to let me know. Okay, all right, team. Any questions from the previous session that we have learned, please let me know. So if you're clear and if you do not have any further questions, please confirm by typing in as all good so that we can proceed ahead with today's agenda. Thank you, Darshan. Thank you, Dheeraj. Thank you, Ramya. Thank you, Sri. Thank you, Kavya. Thank you, Tech Savvy Tools. Okay. Thank you, Kant. Okay, is there any? So I've got a question here. I'm joining in for the first time. Is there any previous recordings available? Yeah, that's a good question, Gopinath. Yes, we do have. I'll be sharing right away. So, folks, the learners who are joining in for the first time. So let me share you the access as. Let me show you share you as how you can access the previous sessions recording. So all the previous sessions recording are made available in the website of Manifold AI Learning. Over here, click on courses. And under this courses, if you browse through in the same page, so there's a page which is dedicated to hands-on machine learning. So over here, you can access the learning content. So for each and every chapter, the learning journey that we had. So we have added the session attachment over here. Okay, and all the individual session attachment will be made available in this page. And even if you have made use of any other content, let's say the presentation or the source code which I'll be creating, so you'll be able to access it in the same portal. I'll be sharing the link over here in the comment section so that everyone can access it. Okay, let me share in the other platforms. I see few learners are also there. Okay, I've shared you the link over here in the comment section, guys. Go ahead and check out the link and register yourself so that you can get the access of the previous session recording. And once the today's session is completed, you'll be able to access the session's recording in the same page once you register yourself. Okay, guys. So thank you again, and I can see folks are dialing in, so that's great. Now let's proceed ahead in our learning journey. Now, before we proceed ahead, just want to give a quick shout out to our sponsors of these sessions. So this session is made possible from the team of Manifold AI Learning. So Manifold AI Learning is a e-learning company who's into providing the self-paced video learning content for the learners on the various topics like data science, machine learning, deep learning, machine learning operations, large language models. So these are the various courses that Manifold AI Learning actually excels in. And if you're someone who is looking out for the content to get started in your learning journey in this generative AI space, I highly recommend you to check out their course in the Manifold AI Learning page. I'll be sharing you the link in the description. So this is the package of generative AI mastery. Now this is a package which is a bundle of more than 10 courses which is there for you to master the generative AI in the learning journey. If you take a look into the package details, if you see right here, so it consists of Python for data science, which is essential for coding, and you'll have the generative AI NLP bootcamp, which takes you through the natural language processing. And there's a course on prompt engineering as well with two projects. This is the latest course you'll get the access to, and to deploy it on the production environment you need a knowledge of cloud, so you'll get the AWS certified machine learning specialty course. The deep learning is covered with the type PyTorch and TensorFlow, and the math concepts that is required for you to understand these generative AI is already part of this overall package. And apart from that, you'll also get the access to the newly in progress course, that is the Python programming for DevOps and MLOps engineer. So these are the various courses which will be part of that single package. And the best part is, as and when the new topics are getting added in this generative AI, you get those access for free. So that's the best part of this generative AI mastery package. I've shared you the link in the description. Go check out. That would help you progress in your learning journey. And I'm one of the instructor from Manifold AI Learning, which have got a chance to create all the courses that you see, which is part of the retail offering. So if you're able, if you like my content, so I'm sure you're gonna enjoy the learning resources which are provided by the Manifold AI Learning. So all make the most of the same, guys. Okay, so let's come back to our session's agenda. Now in the last session that we have seen, so we have looked into the topic of the support vector machine. So let's proceed ahead in this topic of support vector machine and continue further in the learning journey. So let me just bring up the notebook that we were discussing in the last session. So this is the notebook that we were working in the last session. And I had already attached this notebook in the same page that I had shared earlier, that is manifoldlearning.in. If you go to the courses and go to the hands-on machine learning. So I've already provided this as an attachment, that is SVM hands-on. We'll go through the same code and we'll continue further and build the deeper understanding. So folks, will be proceeding in this session, assuming that you're now familiar with the basics of support vector machine. Now, since I can see few learners have joined for the first time, I just want to know from you guys as well, are you comfortable with support vector machine, or do you require any help now? Were you able to follow along from the last session? Please let me know. Sudarshan says yes. Rakshita says yes. Uh, Khan says, can you just give a brief again? Okay, sure. How about others? Santrupti says yes. Okay, I see most of the learners over here are saying as yes. Okay. And okay, one learner have mentioned I have no idea about it. Okay, no worries, guys. We'll do one thing. I'll give a quick background about the support vector machine, and then we'll give a quick overview of what we have discussed till now, and then we will proceed ahead in our learning journey. Now, in the last session, we have looked into this concept of the support vector machine. Now, support vector machine is used for performing both classification and regression. So we were discussing about the classification because that's one of the most widely used application of the support vector machine. Now, when we talk about this support vector machine, we have learned that here, in the case of this support machine, will represent each and every row in my given data set as a data point in n-dimensional space. Once we arrange the data points in the n-dimensional space, then we would go ahead and create a decision boundary in order to split the given data set. I mean, like we'll create a decision boundary to separate the classes. So that's the basic idea about this support vector machine. Okay, so the way it would work is we have seen that here. Okay, so here we can see that suppose if I've got a data points which is in this manner where I've got a data points and I've got multiple data points belongs to the different classes. So we'll try to draw a boundary which separates these data points. Now this line that I'm drawing which separates the data points, we will call this as a hyperplane. So we'll call this as a hyperplane, and we use this hyperplane to split the data points into the individual classes. So that's the idea about the support vector machine. Now, when we are trying to draw, to give you a very high level idea, suppose we've got uh, three lines over here. So I can see A, B, and C. These are the three lines or the three hyperplanes that I've drawn to separate the data points. Now the question that would come is, okay, which one is the one that would be most suitable for this given data? So in this scenario, I can say that the data point, okay, the hyperplane which separates the data points in a maximum extent possible. That means which is at the uh, which is at as much distance as possible from both the classes. So that's the line that we'll be choosing it as a hyperplane. In this case, I can say the line C is the one we can treat it as the best possible. We can see that this line C as the one which which is the best possible uh, line from the given set of data points. Okay, that would be an apt hyperplane for this example. So here, in order to perform the like the way the system would perform the separation is, it will try to draw all the data. It will try to draw the various hyperplane, whichever is the one that separates the data points in a most efficient way, which is as much distance as possible from both the classes. That would be a data point. That would be a hyperplane which is suitable for this given data set. Now here, when we are trying to draw a hyperplane, so in case of support vector machine, we have got an option to specify the type of kernel. So linear kernel is nothing but it's a type of kernel which we would be using where the hyperplane will be in the format of straight line. We've got a polynomial kernel too. So in case of the polynomial kernel, we will be able to draw a polynomial hyperplane where we will transform the data first, and this is then followed by drawing the hyperplane. Okay, then radial basis kernel is nothing but we will transform the given data points with the help of this radial basis function. Then we would go ahead and try to draw the hyperplane on this transform data. So that's the overall idea about the various types of kernel that we have got. Now, here to give you an example, when we are dealing with the non-linear data. So when we are dealing with non-linear data, that's when we would prefer to use this uh, like the non-linear kernel, that is the Gaussian RBF kernel or the polynomial kernel. So what happens is when we have got a data point which is non-linear in nature, where I cannot draw a simple straight line, in such scenarios, we will try to add a new dimension. Maybe we'll transform the existing data points and we'll try to add a new dimension. And once the new dimension is added, then on top of the transformed data points, we will try to draw the hyperplane. So that is the overall idea about this support vector machine. Okay, so to give you the illustration, this is how it would look like. So after the transformation, now I'm able to draw the line which separates the data points. Like to give you an intuition, I'll have a two dimension. I'll add a third dimension which can be of height. Now after I add this third dimension, now I'll be able to draw a hyperplane which separates the data points. So this is the overall idea and the intuition behind the support vector machine. Okay, so that's the overall idea here, team. So basically for the given set of data points, I want to separate into the respective classes. That's the basic idea about the support vector machine. If I'm unable to do it with the help of the linear hyperplane, then I can perform some kind of data points transformation. Then post that, we'll try to separate the data points. So I've got a question here. RS Educational Channel says that is it the best fit line? So it's not directly a best fit line. So what I can say here is it is going to try to draw a hyperplane which we are trying to classify the data points. In the case of best fit line, we are trying to fit the data points where the line output, where the output along the line will be the output for the model. Here in this case, we are trying to draw a hyperplane. You can think of it as a line that you're drawing. We use that line to separate the classes. That's the main difference. Okay, so is this concept now clear, folks? An intuition behind this support vector machine? Okay, thank you, Rakshit. Thank you, Dheeraj. How about others? Is it clear to you now? Okay, perfect. Thank you so much, team, for joining in. Okay, thank you so much, team, for confirming. Okay, now that you are in line with what is happening with the support vector machine, so here in the last session, what we did was we picked up a data set and we started with the scenario of binary classification. Okay, we started with the scenario of this binary classification. Now, in the case of this binary classification, so the way we did is first we just got this iris data set, and for the iris data set, we have converted this multi-class into binary class. So as a result of this, this is how our data points would look like. Okay, so all these data points are belonging to yeah, we'll see. So I've got one set of data points belongs to one class and another set of data points belongs to another class. This is how our data set would look like. Now on this data set, so clearly this is a scenario where I can make use of the simple linear kernel and try to draw the hyperplane which separates the data points. I can draw a hyperplane and this will separate the data points. It's a very straightforward one. So we'll go ahead and implement the support vector machine on this given data set and we'll try to analyze as what is happening over here. Okay, that is what we'll be doing. Now, once we do that, then then we will try to build the intuition around the other topics. Like once we draw the hyperplane, I'll also take you through the other concepts around the support vector machine. So that's what we would be doing. Since most of you are very new to the machine learning and very new to this SVM, I'll take you through in a high level. I'll try to make it as simple as possible. If something is not clear, please feel free to let me know. Okay, so this is how my data points are. So I'll start by instantiating my model. Here, I'm instantiating my support vector classifier. I'll use the kernel as linear. And apart from this kernel as linear, we'll also specify the value of C. So C over here is nothing but it is what we would specify. Okay, it is what we would specify in order to classify the data points. So if I want to make it as a hard classifier, where I'm trying to create a classifier where I'll not allow the misclassification. That's when we will use the value of C as very high. So with C as high, this will be acting like a hard classifier. So I'll be initializing my model and I'll say perform the fit on the given data set. So this would perform the fit on this given data set. And once we perform the fit on this given data set, we'll try to go ahead and display the coefficients. So when I say model.coef, this is going to return the coefficients of the hyperplane. And then if I say model.intercept, this is going to return the intercept value of this hyperplane. Okay, so the intercept and the coefficient is what you see right here. Now, to get the intuition as how it actually look like, what we have tried to build is we have tried to create a decision boundary. Now, one of the learner from the previous session has dropped an email and they had requested me as how this function was actually written. So if you think about it, so here in my given data set, I've got two features, x1 and x2. So if I've got x1 and x2, I'll have two coefficients. I'll call it as w0 and w1. Okay, w0 and w1. These are the coefficients, and I'll have one thing that is called b, which is called it which I'm going to call it as an intercept. So we have a relationship which says that W is equal to W naught x1 plus W1 x2 plus B. So if you think about it, this is basically the linear regression equation that I'm writing. So theta naught plus theta 1 x1 plus theta 2 x2. So similarly, instead of theta naught, I'm mentioning it as B. Theta 1, theta 2 is mentioned as W naught and W1. So based on this, this is the equation of the linear hyperplane, which is a straight line. Now, what we are trying to find is I'm trying to draw the decision boundary. Okay, I'm trying to draw the decision boundary. In order to draw the decision boundary, I have mentioned it in this manner. So I have instantiated for x naught. Okay, so maybe I'll write it in this way, x0 and x1. So what I'm trying to do is, so whatever the x naught okay, so this is the equation of the hyperplane. Now, generally, when we create the hyperplane, this y will be equal to 0, and this would be the overall equation of the hyperplane. The linear hyperplane is given by w naught x naught plus w1 x1 plus b is equal to 0. Now, I have initiated the value of x to some random values. That means I'm left with x1 because I've got W0, I've got W1, and I've got B from this model fit. So this is W0, this is W1, and this is B. 3.78 minus 3.78 is actually B. Okay, now with these value combination, so if I initialize the value of x0 to some random values, then I'll just have to find x1. That x1, I'm calling it as the decision boundary. So if I substitute for x1, so let me move everything to the left hand side. So w1 x1 is equal to minus w0 x0 minus b. Okay, so if I say x1 is equal to minus w0 by w1 times x0 minus b by w1. So this is how the equation will be substituted for my x1. And if you look into this equation for the decision boundary, that mentions the same. I've just basically substituted for x1 over here in this function. So I think that was a question from Srinath. So Srinath, I hope this is clear now. Okay, so we have created the decision boundary like this going. This is nothing but finding the x1 for the data point. Then we have mentioned the margin will be 1 by w1 and the gutter up and the margin. It's nothing but like where exactly my hyperplane would be. That's all. And we'll also draw the dotted line like a gutter up and gutter down is nothing but we'll draw a straight line above we'll draw the straight line on top of my support vectors. So and here we'll just get the support vectors. Support vectors is another term that you would come across in the support vector machine. The support vectors are nothing but the nearest data point of each class is the support vector. Okay, that's the overall idea about the support vector. Now there's one more question I can see over here in the chat window. So Shankar says that what is the range that we have to set for C? Okay, so to answer this, let me take you through the official documentation page of this Scikit-Learn. If I take you to the official documentation for Scikit-Learn, so here This C over here, okay, it's a regularization parameter. Okay, so what it says is the strength of the regularization is inversely proportional to the C. Okay, so and obviously it should always be positive. So that means you'll have, if you mention the largest possible value, then it would set it such a way that it would create it such a way that it will be a hard classifier, and if you reduce it, it will allow for some misclassification. That's how you can think about it, Shankar. And the next question that I see here is B is bias, which is equal to intercept. Yeah, you can think of it in that way. So you can think of that B as a bias term. Okay, great team. So you have looked into the concept of support like function. Now what we will do is we'll mention the model that we have just performed the fit, and we'll try to create a plot. See, if you visualize it, all these data points belongs to one class, blue, and this is another class which is green. And the middle line that you see right here, that is a hyperplane which separates the given data points. Okay, now apart from that, the data point which is present on top of this dotted line, so those data points are called as the support vectors, because these are the data points which are nearest to my hyperplane. So that is the overall intuition behind the support vector machine. And another thing which you need to remember when you're working with this support vector machine is scaling plays a key role in the case of this support vector machine. It is recommended that you scale the data before you apply this support vector machine. So to demonstrate the importance of scaling, there's a code that is already written where first we will apply the support vector machine on the unscaled data, and then we'll apply the scaling. See, if you apply the scaling, as you can clearly see on the right hand side, you'll be able to separate the data points in a much better way compared to the data points which are the unscaled one. Okay, that's the one key thing that you need to remember when you're working with the support vector machine. So scaling plays a key role while working with the support vector machine. Now, another thing that we have learned is when we are working with the support vector machine, not only will be working with the linear kernel, we'll also be dealing with non-linear kernel too. So if we are dealing with non-linear kernel, then uh, like we generally use this non-linear kernel when the data points that we have got cannot be solved with the help of the linear hyperplane. So to give you the idea behind when do we use this, so we'll pick up an example data set. So this is a example data set that I have picked up, which is a dummy data set that has been prepared, which we call it as the make moons data set. So we will use this make moons data set, and we would go ahead and uh, like try to apply the support vector machine and see if it is able to separate my data points. So when you have got the data points, which is in this manner where you have got two classes, okay, you've got two classes of the data. Now with these two classes of the data, so we now want to fit the linear kernel. That means we'll have to draw the decision boundary to separate the data points. Let's see whether it is able to perform the same. So when I've got the data points in this manner, so we'll try to do one thing. We'll try to go ahead and perform the activity of scaling. So since this is the given set of data points, so what we need to do is, as you have already learned, so in order to implement this, we'll have to perform the standard scaling, and scaling should be followed by the implementation of the support vector machine. Now in this case, like we have to do pre-processing and the application of the model. So as practice, we will like when we are experimenting it, we'll generally create it as two different variable. But when you're thinking to write the code, it is always recommended that you make use of one of the most widely used object in the Scikit-Learn, that's called as the Scikit-Learn pipeline. So first, let's understand as how does this Scikit-Learn pipeline is going to work. So to demonstrate this, here I've considered the set of data points. Now, in order to implement the pipeline, so pipeline is nothing but it will take a data, and on top of the data, so when we are using this Scikit-Learn pipeline, I can apply the various pre-processing in a sequential manner for the given data set, and then finally I can perform the fit. Okay, so to link multiple operations and then finally perform the fit, that is when we'll be making use of this Scikit-Learn pipeline. Now in this case, I want to perform the standard scaling first, and this is followed by fitting of the model. So in such scenario, we have implemented this pipeline from the sklearn.pipeline. Then we have created the object for this SVM pipeline, that is the pipeline object. First, we have initialized the standard scaler. Now, once we have initialized the standard scaler, so we have then went ahead and mentioned the model that we want to use. Here in this case, we have mentioned the model as the SVC, that is SVC with kernel as linear. So what it is trying to do is, so first we'll instantiate the pipeline, and once the pipeline have been instantiated, the next thing that we will do is, okay, so when we perform the fit, this pipeline will be applied in a sequential way for the given data set. First, I'll perform the fit of the standard scaler. Then I'll go ahead and perform the fit on the SVC model. In a sequential way, it will perform the fit on the given data set. Like for example, in this case, when I say svm pipeline.fit, it will perform the fit transform. It will perform the fit and transform on the given data. On this transformed output, that is on the scaled output, we will perform the fit of the model. So this is what happens when we go ahead and perform the fit using the Scikit-Learn's pipeline object. So if I execute this, see, first thing it will perform is the standard scaler, and this is followed by fitting of the SVC model. So that is what is going to happen over here when we apply the SVM models fit. And once we perform the fit, if I want to access the individual model, I can go ahead and access the individual model too by by selecting my pipeline object and mentioning the key which we have mentioned. Now, if you try to visualize it, so this time we had actually performed the scaling and applied on the given data set, and this is very much similar to the output that you have seen. So which means if you make use of the pipeline and if you don't make use of the pipeline, the output is same, but when you're making use of the pipeline, it is much helpful, and that's a recommended strategy whenever you are performing the fit using the SVM model. Now what we'll be doing is, in this given data set, see, this is the given data set, and we can see that we cannot make use of our linear kernel and fit the given set of data points. That's not possible. That's not realistically possible for this given set of data points. So what we will be doing is, okay, so what we'll be doing is, we'll first scale the data points. So we will make use of the polynomial features, and we will go ahead. Let me just show here. See, this is my given set of data points. For the given set of data points, I would go ahead and apply the polynomial features with degree 3. Okay, so we'll specify the polynomial features with degree 3. That means we'll apply the transformation on the given set of data points. And once we perform the transformation on the given set of data points, then we'll apply the standard scaler. Then post that, we are applying the SVM model. So this time, this pipeline is performing two data transformation, and this is then followed by the fitting of the support vector machine model. So that's what is happening over here. So we'll just go ahead and perform the fit. Now, once we perform the fit, see polynomial features, standard scalars, followed by the SVM model. Now, if you look into the decision boundary that we have tried to draw, so you can clearly observe the decision boundary that has been drawn. So you can see that the decision boundary is now able to represent the nonlinear relationship between the data points, and I'm now able to separate the data points of two classes as well. So that's the overall intuition behind usage of various kernel. Okay, that's the overall idea of the usage of these various kernel while working with this support vector machine. Okay, team. So I'll take a pause here. So are you able to follow along on this concept of support vector machine and the usage of the nonlinear kernel? So I see a question here. What is the concept of support vectors? Why only 2 points on the line for each side? So to give you the answer, Shankar, I'll answer in two parts. First, it's not it's not something that I'll always have 1 point on each side. So there can also be a scenario where uh, I'll have multiple points on the same line. So that is also a possibility. And the second one is the concept of support vectors is nothing. The importance is here with that support vectors, the model will have better idea. I mean, with that support vectors, it will be an indicator to the model to ensure that the hyperplane is at the equidistant from both the support vectors. That means the data points belongs to the both the classes. Okay, how about others? Any other questions, team? Okay, I can see few learners are now again requesting for the code. So folks, so to access the code, you can just go ahead and visit this URL. So this is where you can download the source code. Let me share again in the chat window too. You can just check the comments in the earlier comments as well. So that's the link that you can use it to access the source code, that a code that I'm using it in the demonstration. Okay, team. So is it clear now? Okay, thank you, Darshan. Thank you, Rakshit, Dheeraj, Ramesh. Okay, excellent, guys. So thank you, team, for confirming. So with this, we'll proceed ahead. Thank you, RS Education. Okay. Uh, okay, so that's the okay. Thank you, folks, for confirming. So now that this concept is clear, so let's proceed further in the learning journey, and let's look into the concepts of the hyperparameter tuning. So here we'll take up some hyperparameters. So here what I'm trying to show you is, so what happens if we change the degree of the polynomial. So to demonstrate this here, this is one polynomial kernel. That means first I'm applying the standard scalar and I'm using the polynomial kernel with degree 3. Then there's another model that I'm creating with degree 100, degree 10. Okay, this is actually the degree 10. Now we'll go ahead and try to visualize the difference. See if you visualize the difference. So with degree 10, okay, with degree 10, so you can see that it is it will try to overfit the given data set. I mean, that's what you would observe when the value of degree is very high. And you can also play around with values of R and C to see how it actually works. Okay, so when the value of C is less, okay, so uh, there can be a little one or two misclassification. When the value of C is very high, it will not allow for misclassification. So these were some of the important hyperparameters of this support vector machine. Okay, team. Now, apart from this, yeah, we have one more kernel that we have got while working with the support vector machine. That's called as the Gaussian RBF kernel. So to demonstrate the usage of this Gaussian RBF kernel, so here I'm creating the pipeline object where we are performing the standard scalar. That means we are applying the standard scalar on the given data set. And then on top of that, we are applying the support vector classifier with the kernel as RBF. That is a radial basis function. So this would go ahead and apply this radial basis function on the given data set. Once it applies it, if we try to visualize it, so this is how the overall radial basis function would look like. So even this radial basis function has got the hyperparameters of gamma and c. We can change the values of this gamma and c and try to visualize how does the overall fit would happen in the case of this support vector machine with the uh, with the kernel like the Gaussian RBF kernel. So folks, what you have learned as part of our learning journey is in the case of the support vector machine. So the support vector machine is a binary classifier and it will draw the hyperplane to separate the data points. Okay. Now while working, if we are dealing with the nonlinear pattern in a given data set, so in such scenarios, we will apply the data transformation. Post the data transformation, we'll go ahead and perform the fit on the given data. So that means we'll try to draw the hyperplane. That's the overall intuition behind the support vector machine. Now, one common question that we would get is the support vector machine supports only binary classification, or do we have a way to perform the multi-class classification with support vector machine? So what is your take on this, guys? So can I apply the multi-class classification type of problems on the support vector machine? So what do you think? So I see multiple responses saying as yes. Okay. Okay, guys. So uh, why and how do you think that it's going to matter? And how do you think this support vector machine can perform the multi-class classification? Okay, so Lakshmikant says that, sir, it can be done with the help of one versus one and one versus test. That's correct, guys. That's correct, Lakshmikant. So, folks, so as Lakshmikant has mentioned, so the way that I can apply the multi-class classification for the given data set, especially with the help of the support vector machine, is by making use of the technique that is one versus one or one versus rest. So let me just show you, I think. Yeah. So whenever we are dealing with the multi-class classification, here the support vector classifier, it makes use of a technique that's called as one versus one scheme. So let me help you understand what exactly is this one versus one scheme. So in the case of this one versus one scheme, so what happens is we are going to train, okay, n different classifiers. Suppose if I have three classes on the given data set, A, B, and C. Okay, these are the three classes in my given data, and it is a multi-class classification. The one versus one model says that I'll train my model by M1 to differentiate whether it is A or B. I'll train my model M2 to say that whether this A versus C. Okay, whichever is the one that is going to, and then I'll train the model 3 to differentiate between B versus C. Now whichever is the combination that is resulting in highest probability, Okay, whichever is the output that we are getting the highest probability, that's the one that we are going to use when it comes to the multi-class classification. And this schema or this scheme is known as the one versus one scheme. Okay, that's the overall intuition behind this one versus one scheme. So it will be creating multiple binary classifiers, and from there the multi-class classification will be performed using this binary classifier of the support vector machine. Okay, guys, so this was about the discussion that we had with support vector machine and the key concepts around this topic of this support vector machine in our learning journey of chapter number 5, which is of support vector machines from the book of hands-on machine learning with scikit-learn, keras, and tensorflow. Okay, now folks, the next chapter that we have got is the decision tree. Now before we move to the decision tree, I'll take a short questions from you. Like, I'll just want to have a quick check-in. So are you able to follow along in these session, guys? So if yes, please confirm. Or do you think if there is any other improvement that you would like to see, do let me know that too. Okay, Rakshit, Seema, Sridhar, uh, Pradeepa. Okay, so I see most of the confirmations as yes. That's great, guys. Okay, all right. Now, thank you so much again, guys, for confirming. Now, folks, the next topic that we have got in this learning journey is basically the decision tree classifier. So we'll do one thing, guys. We'll before we take up the decision tree classifier, we'll take a short break. Now, before we go for a break, so folks, if you're someone, if you're someone who is getting started in the learning journey and wants to know from the basics as how to write the code in Python programming language from the perspective of productionalizing the machine learning model, then I highly recommend you to check out the course from Manifold AI Learning, which is the Python programming for MLOps and DevOps engineer. This is the upcoming course from Manifold AI Learning, which is the early release. So that's the reason that you see the very lowest prices as of now. So with this course, you get to learn some of the important concepts of usage of Python in your DevOps and the MLOps project. Like you learn about the basics of DevOps, and how to make use of automation, Python automation in DevOps workflow, managing the infrastructure with Python, how to deploy and scale the machine learning models with Python, and best practices in Python in DevOps and the MLOps. I highly recommend you to check out this course if you're someone who is getting started and wants to learn more in this Python programming language. Now, as I mentioned, this is an early release. The first batch of videos are expected to drop on April 15th, and as and when the new videos will be added, you get to have the access team. Okay, the other, you can also check out the other courses as well. The latest course which has been completed recently is LLM ops course. You can also check out this course, and if you want the best possible deal, I highly recommend you to check out the package of generative AI mastery which I've shared earlier. Okay, team, so we'll take a short break of 5 minutes, and post 5 minutes we will proceed ahead in the learning journey, team. Okay, definitely, RS, noted down. All right. So, folks, we'll do one thing. We'll go for a short break of 5 minutes. Post that, we'll continue further in the learning journey. Let's meet after 5 minutes. Okay, I hope everyone is back, team. Now, moving on, the next chapter or the next topic that we have got as part of our learning journey is the decision tree. Now, let me just try to give you a high level intuition behind this decision tree. And once you have that high level intuition, it will be much clearer for you to follow along. So, to help you understand the same, okay, let me take you through the illustration of this decision tree so that you can get a clear perspective as how does this decision tree algorithm is going to work. Now, when we talk about this decision tree model, so decision tree model is a model which we generally use it for both classification and regression. And it's a very simple model, and it's one of the powerful model that we have got in machine learning. So when we talk about this decision tree, so a decision tree, to illustrate this, so I want you to just consider this example. So let's say you want to decide whether you want to go to a restaurant or whether you want to go to a home. Okay, this is what you need to decide. You need to decide whether to go to a restaurant or whether you want to go to a home. Okay, so in such scenario, okay, so this is how the decision would go for an individual. Okay, let's consider that individual is a college student, and this college student wants to decide whether he wants to go to a restaurant or a home. Then in such case, obviously, he'll check whether he's hungry or not. So if he's hungry, then he'll check whether he has got enough money from his pocket. Okay, so and then if he's got more than 1000 rupees, then if he's hungry, then maybe he'll plan for Novotel. If he do not have any money, maybe he'll go to a South Kitchen, which is like a famous joint in Bangalore city, which is an economical one. So basically, depending on the answer for the question, like first question was whether he's hungry or not. If he's hungry, so he'll ask the next question whether I'm having enough money or not. And based on that answer, so we'll also have the next action will be taken whether to go to the Novotel or the South Kitchen. So if the person is not hungry, okay, then he'll simply go home and sleep. So basically, if you have understood this example of various decision and the action, then I can simply say that you have understood the decision tree algorithm. It's a very simple algorithm, and it's one of the very powerful algorithms. So what happens is whenever we have got the data set, on the given data set, the system is going to ask similar kind of questions, and then it will split the data points on the basis of the answer to those questions. And finally, it will be able to separate the data points to the respective classes. So that's the idea about this decision tree classifier or the decision tree working. Now, when we are constructing this decision tree, so this decision tree is a simple representation for classifying the examples, and it's a supervised machine learning. Now, what we'll be doing in this case is we are going to split the data according to a certain parameter. That's the idea about this decision tree algorithm. Now in this decision tree, so when we construct it, each decision tree will have the nodes, edges or branch or the leaf node. So these are all the parts of decision tree. So to give you the importance and to share some more details about this decision tree, so consider the diagram that you see right here. So let's consider that we've got the diagram and we want to ask, okay, we want to answer a question that says that whether the person is fit or not. Okay, I want to answer whether the person is fit or not. So to answer this question as whether this person is fit or not, then we have got the series of questions. So first question over here says that whether what is the age of the person, whether the age of this person is less than 30. Okay, if it is less than 30, Then I'm going to ask the next question whether he eats lots of pizzas. So if no, he's fit. Okay, if he eats lots of pizza, then he's unfit. The other question is whether this person, on the other hand, if the person's age is more than 30, okay, then in this scenario, I'm saying that I'm checking whether he or she does the exercise in the morning. If yes, the person is fit, else it is unfit. So that's how a simple illustration of the decision tree would look like. Now you can clearly see we'll be asking the question, and based on the answer to that question, we'll be taking a decision. So when we construct the decision tree, if I want to describe the parts, so this is how the various parts of the decision tree would look like. So here you can clearly observe that on the top we have got the root node. So root node is a place which gets the entire data set. And from that root node, we will ask a question. Okay. From that root node, we are going to ask a question. Now, based on the answer to that question, we would go ahead and reach the further node. So on top, we have got the root node, and followed by we've got the individual decision node based on the answer or to my original root node. Then we would further go ahead and split the data set. We'll ask the question and we'll further go ahead and split the data set into the respective nodes. So that's the overall idea here, team. Now, the final node, the node where the further split does not happen, we call that node as a leaf node. Leaf node is a node where there is no further split would happen on the data set. That is called as a leaf node. So this is how the various parts of the decision tree would look like. So root node, decision node, and a leaf node. So if I want to describe the types, as I mentioned in the beginning, so there are two types of decision tree. One is classification tree and the other one is the regression tree. In the case of this classification, we will make use of the technique, we'll follow an iterative process where we will split the data set into individual partition. In case of regression tree, so we even in this case we'll split the data set, but here when we are describing the overall output, we'll take up the average of those data points. So that's the overall idea about this regression decision trees. Okay, now the method that is followed in the case of this decision tree is called as the divide and conquer method. So what happens in the case of this divide and conquer method is we'll select a test for the root node. Okay, we'll select the test for the root node. That means for the given data set, we'll decide, okay, what is the question that we need to ask, and based on the outcome of the test, it will split into subset, and we'll continue to do this process for each and every branch using the instances that reach that individual branch, and we will stop the splitting if all the instances are having the same class. So that's the idea and the working of this decision tree algorithm, guys. So here, the way in which it would work is, see, we'll start with complete data set. We'll decide on the measure of impurity. So this is an important one. When you're constructing the decision tree, you need to specify which value that my model has to consider when it is splitting the data points. So here, the value that we would specify is basically the loss function. So in decision tree, there are two most commonly used loss function. One is Gini impurity index and the other one is the entropy. So this is one of the hyperparameter. It is up to us as which one to use. So we'll specify the loss function which it has to consider for performing the split, and then once then what it will do in the backend is it will decide which feature it has to consider when it is performing the split. Okay, so which condition or the which question it has to ask, it will decide in the backend, and then it will go ahead and generate the business rule. So it will become very much clear once we implement it on the data set itself, team. To give you in the backend, so here when we talk about the Gini impurity index and the entropy, the equation of Gini impurity index is 1 minus sigma of I is equal to 1 P of Ci whole square, and entropy is minus P of Ci multiplied with log to the base 2 of P of Ci. So we can use either of these loss function when we are constructing the decision tree. So the idea is whenever we are performing the split and constructing the decision tree, so we want to split such a way that, okay, we want to split such a way that the loss values are reduced. Okay, so let's go ahead and implement this decision tree classifier on this example, and that will give you a clear perspective as how it actually done. So let me just show you guys, okay, if you are thinking about implementing it. So for like we've got one example that I've got that is present right here. This is from the data set that's called as a breast cancer data set. Now for this given data set, we want to classify the data points are whether the breast cancer is malignant or benign. Okay, so here we've got various features in the given data set. We've got the features like radius, texture, area, smoothness. So like this, we've got various features. So we will try to find the relationship between this feature and the target. Now, when it comes to the implementation, so this decision tree classifier is available from the sklearn. We'll say from sklearn.tree, and we would go ahead and import this decision tree classifier. We'll create the classifier object, and we would go ahead and perform the fit. The important thing that you have to remember is this. Okay, so the important thing that you need to remember is this is how the decision tree output would be present. So here you will have the entire data set. This will be the root node, and you can see that on the population it is 0.468. So that's the value of Gini impurity index on the entire data set at the root node. Then we have splitted the data set from the root node. We have asked the question. The question over here says that whether the worst perimeter is less than or equal to 115.35. That's the question it has asked. Now, based on the answer to the question, that is true or false, we have the respective branch that is getting populated. And if you look at it, as and when we go down from the root branch to the root node to the other nodes, okay, the overall impurity will be reduced. So that's the overall intuition that you need to remember when you are constructing the decision tree algorithm. Okay, so you can see the values are getting split, and you can see each time based on the answer to that question, the values are getting populated. So that's the overall intuition behind this decision tree model or this decision tree classifier. All right, folks, now that you have the theoretical understanding of this decision tree model, so let's go ahead and implement it on one of the data set so that you'll get a better understanding as how it actually works. So let's go ahead and try to understand as how to work with this decision tree model. So decision tree classifier demo. Okay, so let me just take you through the steps. So first thing that I'll be doing is I'll start by importing the data set. So the data set that I'll be using is the breast cancer data set from sklearn.dataset. I'll be importing the breast cancer data set. So load breast cancer, and I'll load this data set. Now, once I load the data, we'll also import the necessary libraries. So pandas as PD, numpy as np, and we'll also import the matplotlib as well. Okay, now once we import the necessary libraries, we'll load the feature and target. So x is equal to cancer.data, y is equal to cancer.target. So this is going to separate the feature and target. Okay, now once we separate the feature and the target, if I just show you the X, I'll just display first 5 rows. So this is how the first 5 rows of the given data would look like. Okay, that's how the first 5 rows would look like. Now, what we'll do is, since we have got the features and we have the target, we'll try to like we can actually, I can show you what exactly this data is all about. Let me show you that, okay, before we split the data. So So this is how the data is all about. Okay, we've got various columns: mean radius, mean texture, mean perimeter. So this is how the data frame would look like. And the target is basically the y. So here, if you look into the values of y, and if I now display the first few entries of this data frame, so I've got a column which is target now. It is a binary classification. It basically contains 0 or 1. So we have so we are now performing the task of binary classification using the model of decision tree classifier. So that is what we are currently doing right here. Okay, this is a decision tree classifier. So now, since you have got the data and you know what exactly is the type of problem that we are solving, so let's try to split the data set, because that's a very common thing that we will do in any machine learning. So I'll just split the data set using the sklearn library. From sklearn dot model underscore selection, I'll import train test split. Okay, then we'll say xtrain comma xtest ytrain comma ytest is equal to train test split x comma y comma. Now whenever we are performing the split, okay, we can actually perform the stratified split as well. If I say stratify is equal to y, so what impact it will have is, it will ensure that whatever the data distribution that we have got in column y, the same data distribution will be considered while performing the split as well. So this is a common way in which we would actually perform this activity. I'll say random state as phi. Okay, so this would go ahead and perform the split. Now once we perform the split, we'll try to implement our decision tree classifier. So from sklearn dot tree, we'll import our decision tree classifier. I'll say dt is equal to decision tree classifier, and we'll specify some random state. Okay, now we'll perform the fit on this given data set, xtrain comma ytrain. Now once we perform the fit, okay, let's try to generate the prediction. I'll say ypred is equal to dt dot predict, and we'll send in our x test. Now let's try to check the overall accuracy of the model. So from sklearn dot metrics, I'm going to import accuracy score and F1 score. So let's calculate the accuracy score. So I'll send in my y test and ypred. So okay, it's ypred.
So the accuracy is 92.30. Let's check the F1 score. The F1 score that we are getting on this given data is 0.93, which is actually very good on this given data set, which says that, okay, how powerful this model is. So guys, let's try to visualize how exactly this decision tree has been constructed. So in order to visualize this, let me just install some of the necessary libraries in this Google Colab environment. One thing that we would require is the Graphviz. And apart from that, so let me just write the code. So I'm going to import the export Graphviz, and then we'll make use of this export Graphviz function, and we'll export it in a ODT format by specifying the model. Okay, then we would go ahead and create a graph, and we'll try to visualize it. So if I try to visualize our decision tree model which has been created, so this is how the decision tree model that we have constructed would look like. So by making use of the default values of the hyperparameters, the decision tree model has constructed a tree-like structure which describes the pattern in my data set. So I've got the to start with, there's a worst parameter perimeter, and based on that it has performed the split, and it went ahead and created the split. So on top we have got the root node. Okay, and in each and every node we are going to ask a question. Based on the answer to that question, we'll split the data into into the two ways, like whether it is true or false. So that's the overall idea in which the decision tree will be constructed. Okay, we can see that the decision tree has been constructed, and once we have reached a point where we have all the data points belongs to a same class, then that is a scenario where we say that that's a leaf node. So we have reached a point in a leaf node. So that's the overall intuition behind this decision tree algorithm, and it will split such a way that the value of loss will be minimized. Now, you might be wondering, as we didn't specify any value of loss function. Now, which value has it actually picked up? So in this case, okay, the value that it got picked up is uh, basically, let me just take you to the documentation page, Scikit-Learn decision tree. If I take you to this decision tree classifier, see, by default, the criterion has been considered as Gini. So the Gini impurity index has been considered over here for performing the fit. If I want, I can now go ahead and make use of different combination as well. Like I can try it out for entropy for the given data. And another key thing that you need to remember is, like this time, since I did not mention any condition for the depth of the decision tree, so it took the maximum possible depth for the given data set. So here we can also perform the fine tuning by specifying the maximum depth as well. Now, apart from that, we can also perform the fine tuning by specifying the minimum sample split, minimum sample leaf, and these are the other values that we can specify in order to perform the fine tuning. So let's go ahead and perform the hyperparameter tuning on this decision tree algorithm too. So you have seen the basic idea of constructing this decision tree. So let's perform the hyperparameter tuning. For performing the hyperparameter tuning, we'll make use of the grid search CV. So I'll import grid search CV, and we'll create in this manner. I'll say tune parameters is equal to, I'll be creating it in this manner. So criterion, okay, the values that I'll consider are Gini, comma, uh, entropy, Okay, and I'll also specify the maximum depth. So for the maximum depth, I'll consider the values with the range of, let's say, 2 comma 20. Now we'll instantiate our model. I'll say CLF underscore tree, that means classifier tree, is equal to decision tree classifier, and then we'll perform the grid search CV. CLF tree, okay, I'll say grid CLF is equal to grid search CV. Here we'll have to mention our model CLF underscore tree. This is followed by mentioning our hyperparameters tuned underscore parameters, that is hyperparameter range. I'll mention the cross validation as 10. Okay, that means it will perform 10-fold cross validation, and we'll make use of the scoring as ROC AUC. You can use anything. So just for the change, I'm making use of this ROC AUC metric. So let's execute this. Now we have created the model. Now once we have created this grid search CV, we'll perform the fit on this given data set. So xtrain comma ytrain. Now once we perform the fit, so this will take a while, and then we can check the overall best performing model. So CLF dot best score. So the best score that we have reached from this model by considering the ROC AUC is 0.9544. That's a really good one. Let's check the best parameters. If I say best paramps, so it basically displays what are the best values of the hyperparameters which gave us the better output. It says that with criterion as entropy and maximum depth as 3, we got the best performing model for the given data set. So now you can actually get the model. I'll say guess best underscore model is equal to grade underscore CLF dot, so best estimator. Now I can go ahead and perform the fit with this model. We can perform the fit again on this given data set, and you can generate the prediction. So let me do one thing. I'll just copy paste the previous one that we had mentioned earlier. So we'll try to visualize our best model. So if you try to visualize the best model that we have just created, see, this is how the overall best model would look like. So the depth is 3, and like it has considered the entropy. All right, guys. So that's the overall idea about working with this decision tree model. So what you have learned as part of this today's session is you have learned about the support vector machine and also built a solid understanding about the decision tree model, that is the decision tree classifier. So folks, I want to know from you, uh, do you have any questions or any queries from this session on decision tree classifier or the support vector machine? So if you're clear, please confirm by typing as all good. Or if you have got any question, please do let me know. Okay, Lakshmikant, Samyukta. Okay, thank you. Thank you, Kavya, Neeraj, Ramesh. Perfect. Thank you so much, team, for confirming. Now I'll be attaching this notebook into your LMS. Okay, like I'll be attaching in the same portal that I have shown you earlier. So post the session, you'll be able to download it from that link. Okay, you'll be able to download it from the hands-on machine learning. So I'll just go directly over here, and today's session is actually chapter 5. So chapter 6, decision tree classifier. So under this, I'll be uploading our source code. Okay, I've uploaded the source code, and once the session is completed, you'll also be able to access the session's recording in the same link. Let me share you the link again. So this is the link which you can use it for accessing the source code. Okay, guys. So with this, we come to the end of today's session on the chapter 5 and chapter 6, and more specifically, the support vector machines and the decision tree classifier. So if you're someone who's new to ML ops, and if you're someone who's curious to know as how to take your machine learning models to the production environment, do check out the courses from Manifold AI Learning. So there's a sale that's going on in the Manifold AI Learning. So do check out their page so that you can get the most of the upcoming offers that is running in. So I look forward to seeing you on the next session, everyone. Thank you so much, everyone, for taking your time and joining in with me on this live session. So I'll see you on the next webinar. So if you have registered for the other webinar, so there's a next webinar which is starting in next 30 minutes, which is about the topic of how to deploy your machine learning models in the with the help of AWS. Okay, it's a very interesting webinar. So for those of you who have not registered, let me share you the link right away. So use the link that I have just shared to you. If you have not registered earlier, use this link to get yourself registered, and I'll see you on the next session where we'll be looking into the topic of how to deploy the machine learning models using the AWS. Okay, so I'll see you in the next webinar, everyone. So take care. So I'll be here for 2 more minutes. In case if anyone has any questions, please do let me know. Thank you, guys. Thank you, team. Take care.